Now in this video, we're going to be discussing how to manage messages in graph state. We're going to be walking things from simple to standard. Yeah. And definitely, as usual, we're going to be wrapping things up with a demo where we can see the tools that LangGraph rather provides for us to work with messages. Now, as we all know, there are three common messages. We have the AI message, or rather, let's start from the human message. We have the human message. Now, the human message is the message you send. Any message that comes from you, or probably you type into the system to be sent to the LLM, that is a human message. That is a human message. So either it is coming from a real human input, or your application is actually sending the prompt directly to the LLM. That is considered a human message. Then we have an AI message. We have an AI message. And an AI message, also called an assistant message, is basically your response from the LLM. That is your response from the LLM. So the response you get back from the LLM, whichever mode it is, text, image, whatever, that is the AI message. That is an AI message. Now, we also have a tool message. We have a tool message, which you can argue is a subset of an AI message because it is also a response by the LLM. But this is the tool suggestion or the tool call object that the LLM sends. So if you provide tools in your LLM call and the LLM analyzes the prompt and says that a tool is necessary, it's actually going to return a tool message. It's going to return the suggestion for the tool to call and also the arguments that you have to call the tool function with. So we have the tool message. There are also other messages like system message. Let's put system message there because it's also very useful and powerful. So system message, this for you to kind of like give instructions to the model at the very beginning of your conversation so that instruction kind of carries through the particular request or even the entire conversation that you have. So for example, let's say you want the LLM to, for some reason, always answer you in French. So at the beginning, you can set a system message and tell it that give me all responses in French. So yeah, those are messages. And there are different ways you can manage them within your graphs. Now, to manage a set of messages, you need a state variable to hold the messages. And the state variable is definitely going to come as a list because you are going to be holding, or most likely going to be holding, more than one message. So you're going to have a list to hold your message. So let's say you have your agent state, and within your agent state, you define a state variable called messages. So you can set that to list. You can say a list of strings. So this is one way you can set, define the variable that is going to hold your LLM messages. This is just a simple way. You want to hold them as strings and nothing more. Fine. Now, if it remains this way, you are using the default reducer. So you won't be able to actually have a conversational history. Every new message is going to replace the previous one. Every new message is going to replace the previous one. Or any new list is going to replace the previous list. So if you want to be managing it that way, where you just swap in the entire new list with the old list, if that is what your use case requires, then fine. But most likely not. You would often need to provide a reducer. You need to provide a custom reducer specifically because this is the default reducer. So you need to provide a custom reducer. And one example is something like the add operator, the add function rather from the operator library. So to do that, first you have to annotate this definition, and then you come here and add the add function as your reducer. Well, let's just say operator.add. So operator.add. Yeah. So you say operator.add, and that way, anytime you add a new item to this list, it will be appended to the list. It's not going to override the entire list. It's going to be appended to the list. So that's all fine and good. This way, you don't get your whole conversational history just wiped off. However, with something like this, you won't be able to for you to work with two messages is going to be a bit difficult because two messages are not plain strings. they are structured as a part, a prompt part or a message part that has a particular structure that it has to follow for the LLM to be able to read it. So if you're going to be using two messages, this probably won't work. So you want to go with something like the LangGraph add messages with user. I want to go with LangGraph add messages with user because it helps you to work with things like two messages. It also helps you to properly handle human in the loop. So anytime you have that interruption whereby you can intervene in the model's operation, add messages will help you to convert whatever you put in, whatever your input is as the human. It will help you to add it to the conversation history as a human message. So yeah, now this is our structure. This is what we're working with. We have add messages, and this is definitely okay. This is perfect. This is wonderful for you to use as the state variable definition in your graph. Now, because this setup is common, because this setup is very common, LangGraph actually provides a class called MessagesState. Yeah, MessagesState. So we have it's MessagesState, and yeah. Now before we talk about MessagesState, one more thing here. So by the time you start using add messages, it's better you define this as a base message. So once you start using add messages, this becomes base message because you now don't have a list of strings. You actually have a list of message types. You have a list of standard LangChain message types, so that when add messages is adding to this list, there won't be any errors. It won't throw an error. So have base message, and we're using base message because it is the base class for every type of message in LangChain. Yeah. Now when I see me saying LangChain, I was like, are we not talking about LangGraph? Yeah, messages come from LangChain. Message definitions come from LangChain. And even when you are bringing in their classes, they're going to be from the LangChain package. But once you install LangGraph, it already comes bundled with LangChain, so you can actually just pull any of the LangChain classes that are in the core package, not the ones in the community or the ones that are from other specific vendor packages like LangChain OpenAI or LangChain for Google Generative AI. So base message is going to apply to any type of message, so that when add messages is adding any type of message, be it tool message, human message, or any type of message, this applies. So then this whole setup, LangGraph provides a MessagesState class. A MessagesState class. You can just use this class as your state. If you would only have messages, if you only be working with LLM messages, you can simply just use this class as your state. So you can do something like this. You can just say your graph should be equal to state graph, and you pass in messages state. Passing messages state. Yeah. And all this is available to you. You have all these already. You don't have to write every single thing here. You have a messages key in your state. It will be annotated. It will be a list of base message, and it will be using the add messages with user. So yeah, that's just a lovely helper for you to do that. But sometimes, in a lot of times, actually, you don't just want to keep messages in your state. You want to keep other things. Yeah, you want to keep other things. You want to keep other state variables in your state. And you want to, let's say you still want to take advantage of this MessagesState class. So what you can do is that you can define a new agent state. You can simply just define a new agent state. And that agent state is going to inherit from MessagesState. To inherit from MessagesState. And that way you already have all this entire setup. So you don't have to write all this. You have this entire setup. You already have a state variable that's going to manage your messages, and it uses the add messages with user. And you can go into your class and still go ahead and add other variables, like say step count. You can add other variables like step count, and just keep adding all the variables you need in your state. So yeah, this is how you can actually take advantage of MessagesState and also still use your agent state class in the usual way, adding other variables that you might need. Now, this is all about setting up messages, setting up a state variable for you to handle your messages and making sure that your messages are properly handled. But what about accessing messages? How do you access messages in your state? So for accessing messages, let me just use this area. So let me bring this guy here. Let me use this area. Now, messages appear in state in two ways. They appear in state in two ways. So in your list of messages, so you have your state, you have the messages key. So in your list of messages, you have the list, and they can either appear in the class form. Let's say human message content. My message content equals blah blah blah. So human message content, so they can appear this way. That's one way they can appear. And let me just copy this and duplicate it. Another way it can appear is not using the class syntax, but using the dictionary syntax. So you have another dictionary in here. And let's say for your first message, which is a human message, it will have a role key, and the role will be set to human. Then it will have a content key, and that will be set to what your message is. Yeah. So your messages can either be stored in your messages state variable this way using the class syntax, or this way using the dictionary syntax. So either way, you can actually access them the same way. You can access them the same way. So if I'm going to access this, I'm simply going to say state messages, state messages. So I get my messages key from state. And let's say I want to get, let's say the last message, the very last message. I say -1 and say dot content. Because content is actually what gives you the textual representation of your message. So if you want to access your state message, you just say state, get the messages key. I want to access the last message, so I'll say -1 and dot content, and to give you the string representation of your message, of your actual message. It can be, and that can be a human message, a system message. I don't know how a tool message is going to come out, but I believe it will still be in the content key. So probably that will return a dictionary of the content of the function call definition. So yeah, but everything is going to be stored in content. So yeah, that's your beginner crash course in messages in graph state. Now let's go into VS Code and write some code. So in this demo, we're going to be taking advantage of that messages state class. Yeah, we're going to be taking advantage of that because in previous examples, we've actually been writing the whole thing, the whole messages definition with a list of base messages and also using the add messages with user. But now we're going to be taking advantage of the messages state class and also adding like one extra state variable to the mix. We're going to be doing that, and we're basically going to be showing how to access the state, how to add messages, and also how to update another state variable that is not part of the messages state. So we're actually going to create one node for each of that. So our graph is just going to run through all the nodes. One is going to access state, one is going to add to state, that's the messages state itself, and the third one is going to update the other custom states that we are using in our messages state. So let me stop saying state all the time and just get to work. So let's say messages state demo.py. Let's start that way. The first thing we're going to do is to bring in our classes. So first with the classes that will help us in defining our state. Say from typing, import annotated, typed dict, and lists. So to begin, first let us bring in our graph classes. So I'm going to say LangGraph.graph, import, we need state graph, we need start, we also need end, and our magical messages state class also comes from this package. So let's say messages state. So that's good. I spelled state graph wrong. Yeah. So state graph, start and end. Those are the things we need to create our graph. So next we're going to bring in some message classes from LangChain core. So it's LangChain core.messages. Like I said, messages belong in the LangChain package, but installing LangGraph gives you access to it, so you can always pull in the classes. So say from here, you should import. And for adding messages, we'll need a human message. And for adding an AI message, for working with an AI message, let me just use an AI message. Because in this demo, we're not going to be using an LLM, we're going to be adding a fabricated AI message. Yeah. So we get these two in. Now let us continue. So the first thing we're going to do is create our state class. And I'm going to call that my graph state. And like I said, we're going to be making use of the wonderful MessagesState class, which gives us access to a messages key and add messages automatically. So we'll say messages state. We're inheriting from it because we want to add another variable into the mix. So for here, I'm just going to say turn count int. Yeah, let's just yeah, we'll know what that does later. So yeah, turn count an integer. Just put that in. Now let us add our nodes. Let's add our nodes. And like I said, we're going to add a node to demonstrate how we can retrieve states. We're going to add another node where we're going to show how we can append to our message list. And I'm also going to write another node where we just simply update turn count, just to show that, yeah, you can also update other variables aside the messages variable that comes with MessagesState. Start with the node that adds a message. I'm going to say define user node. Define user node. It will take in states, which will definitely be an instance of our graph state. This node is going to return a dictionary, which is kind of implied at this point. Well, let me do that correctly. So here we can then, I'll just put a message here first so that it can appear. We can see the process in our command line. We can see which node is running. So executing user node. Let me put it in quotes. Executing user node. So executing user node, and what we'll simply do here is to add a user message to our state. So I'm just going to return messages, and I'm just going to set this equal to a human message. Content equals. For this, I'll just say, what is the weather like today? What is the weather like today? So that's good. No, come on. So that's good. That is a node that adds a message. Now let's create another node. I'm going to call it AI node. And this node is going to do two things. It is going to access the previous state. It's going to access our messages key in the state, and to also add our fabricated AI message. So it kind of be like the response to this question. So let's put graph state again, my graph state. Just going to assume the dictionary part of this function because we already know it returns a dictionary. Now inside here, first I'm going to say print executing AI node. Executing AI node, so now we know that this is what we're currently doing. And we're going to access, let us access our state. Let us access the last message in our state. So I'm going to say last message. And I'm going to set that to state messages. I'm just going to say -1 dot content. And we're just going to print this out. I'm going to say human prompt. Let us use f-string so that we can have that variable in here. So last message. So yeah, human prompt last message. And now let us fabricate our AI response to this message. First, I'm going to say response content equals, and then I'm just going to write a goofy message where I will say, I have received your message, which is last message. I've received your message. Let's close this. I've received your message. However, I am a fake response and can't respond. Then I'll put a new line here and say, but at least my code is working. But at least my code is working. Oh, we have, okay. So yeah, that's the response we're going to give. Yeah, we will receive the human message, but we can't respond. It's a fake AI. So, but the code is working. Things are working. So we can return this and tack it on to messages. And we just set this to an AI message. An AI message where we can set the content to be equal to this. Yeah. So that's our AI node. It just creates a fake response and we tack it onto our messages array, or our messages list rather, as an AI message. So that's good. Now, the last node we're going to create is the one that just simply updates the turn count. Yeah, turn count variable. So it's for every turn, not for every node hop. It's for every turn. So it's going to be the last node, and it's going to register that. Oh yeah, this turn is done, so I can register 1. Then if you run it again, 2. Run it again, 3. So it's basically be incrementing. So let's define that. Going to call it counter node, which will also take in state. State being an instance of my graph state. I'm also just going to assume the dictionary that will be returned. And inside here, I'm going to print and say executing counter node. And we can simply return an update to turn count. So turn count. We'll also access our states. Say turn count. This is something that could have used a custom reducer from operator, but I'm just going to do it manually. So say +1. Yeah, turn count +1. Turn count starts at 0, right? Yeah, we'll define that when we initialize the graph. So yeah, we have this and everything looks fine. We have our 3 nodes. Now let us build our graph. So we come down here. So say graph equals state graph, and let us pass in our agent state, which is my graph state. Let's pass this in, and next thing we're going to do is add our nodes. So let us quickly do that. Graph.add node. Now you can just add your nodes with functions. With the functions, it will assume the name, so I'm just going to add them that way so we can run through this quickly. So we had add node, or rather user node, graph.add node again, and the next is going to be our AI node, and we can also say graph.add node, give this our counter node. This is good. That is good. Now let us connect everything with edges. Let's connect everything with edges. We're going to start, go to the user node, go to the AI node, then go to the counter node and terminate. So let us run through that. So graph.add edge. Say start. From start, go to user node. Then let me just copy this and let's edit. So then we go from user node to AI node. After that, we'll then go from AI node to counter node. Counter node. And finally, we can go from counter node and terminate our graph. So from start to user, user to AI, AI to counter, counter to the end. So yeah, we have our graph, and now we can compile it. So let's call it agent, and let us take the graph and call the compile function. So we now have our graph returned as a runnable, which we have called agent. Now we can pass inputs into it. We can pass input into it and run different turns. So for this example, I'm just going to be running one turn. So I'll create an initial state. We don't need to do anything for the messages variable. The whole messages state setup is going to handle that. So we only need to have turn count with its initial value, which I'll set to 0. We can then say final state. Now final state will be us invoking this agent with our initial state. We can then print the final state of this operation. Let's have final state and simply print that. Final state. Print final state. Perfect. So let us run this example. Yeah, we've been building for quite a while. Now let us run this example. Let us pull up the command line, and now say Python MessagesState demo.py. Hoping the demo gods are behind us so that we don't run into any errors. Yeah, boom. Everything runs quickly. We use a fake AI message. So as we were calling an LLM, definitely there will be some latency in between that. But yeah, let's see what we have. Executing user node, executing AI node. When it got into the AI node, it accessed the human prompt, which says, what is the weather like today? And then it executed the counter node. At the end of the day, the final state that we have is we have our messages. You see that messages array is already there. You don't need to put it there. So inside our messages, we have the first human message that we sent, which is what is the weather like today? And then we have the AI message that we sent in. And if we look at that AI message, if we look at the contents property, it says, I have received your message. What is the weather like today? Which is what came from here. And it says, however, I am a fake response and can't respond, but at least my code is working. Awesome, awesome, awesome. And as we can see, turn count incremented to 1 because we went one turn. Turn count incremented to 1. So in this demo, we've seen how to take advantage of MessagesState. How we've been able to use it to manage our message sequence. If we're using an LLM, we'll seamlessly manage our conversation history. And we also saw that we can actually use it within inherit it so that we can have other variables in our state class. And we've been able to see that with turn count. And we can also update that state variable alongside our messages state variable.